These are extremophiles. What is that? Phile means love. These are lovers of extreme conditions. Like they can be found in growing in hotter than boiling water. First discovered in Yellowstone National Park some 30 years ago or so. These are this famous archaebacteria. They're so different from other bacteria that they're put in their own, even in their own domain, actually. Not just kingdom, they're in their own domain. And some can be living in extremely salty conditions like the Dead Sea in Israel or Great Salt Lake in Utah. Those are called halophiles, salt lovers. Really amazing bacteria. Yes?
Because they live in extreme conditions, do they ever live in normal conditions?
Do any archaebacteria live in normal conditions? Maybe. You know what? That's a great question. We always read about the extremophiles, actually. So I don't know much about that. Probably some do. And you just don't hear about them because they're not as flashy. But the next slide shows top view of a boiling hot lake in Yellowstone National Park. See the road, see the people walking along the road. And look at all those different species of bacteria. Each species lives at a different temperature. Okay, cooler, hotter, hotter, hotter. These are the archaebacteria. Fascinating organisms in evolution. We think eukaryotic cells may have evolved from archaebacteria, actually, in many profound ways. And then the last slide in this set is just a picture of a meteorite from Mars that landed on Antarctica. You know, when you walk around in Antarctica, it's all snow, but once in a while you'll see this black rock sitting on top of the snow. Where the hell did that thing come from? And we're pretty sure those are meteorites that came from Mars. Blown away, put into orbit. A meteor hits Mars, sends up a spray of rock, goes into unstable orbit, eventually captured by the Earth's gravitational field, and they fall to Earth. And if they fall in the ocean, no one discovers them, of course, but when they chance to fall on Antarctica on the snow, you see them, and you can pick them up, and these are rocks from Mars. And about 20 years ago, one of these probably Martian meteorites attracted a lot of attention because they found this under a microscope and they thought it was evidence of a fossilized bacteria. Now we think this probably wasn't bacteria. That's the best guess, actually. But you know, what is it up there? What's the name of the thing on Mars? Opportunity? No. Rover.
The new one?
Yeah, the new one. Not Spirit, not Opportunity.
Curiosity.
Huh?
Curiosity.
Curiosity, right. Curiosity's up there doing some really sophisticated tests for organic molecules and signs of life. So maybe Mars had life once. Frankly, I kind of doubt it, but maybe. Used to have water, used to be a much warmer planet. So that's kind of an exciting thing that NASA's looking into. All right, so when we look at the bacteria, you'll see in the study packet some pages to look over in preparation for the lab. Just read those over. We're going to talk about diffusion and osmosis. I'd like you to look over those pages. We're going to try to do a little bit of mathematics on that as well as time permits. Now, this is a screwed up week because the day class didn't meet yesterday, so I'm all fouled up. And got to get the two classes back in sync with each other. So I believe we're going to end tonight. You're going to need to come up, give me your name sign again. Let's turn on these lights. I'll give you 20 points.